But yeah, we'll hook this up and see if I can get a square wave coming out of here. That'll simulate the cam position sensor. And okay, we are getting a square wave.
Hi, honey.
Oh, it's Jana.
It's me. What are you doing?
Well, if you must know, I'm sciencing hardcore. Can't you see it?
I can tell by all the piles.
All the piles?
Look what I got.
Some kind of lizard head?
It's a candle.
Oh my gosh.
Ah. Isn't it cool? The eyeballs?
Oh yeah.
Yeah. It's heavy.
Yeah. So now, we've done a bunch of playing around with this stuff. Go out to the car. Alright, so the problem is this, like I was showing in the picture, these are wired backwards. This red wire and this brown wire are backwards. So we're gonna fit them out. It's got this little, little poker thing. And I'm just gonna slide it up in here. Pull that out, just right there. You put it on that little slot on the top, like up there, above. You just push it in, it pushes the tab down, good to go. Then just pull it out, push the tab back down, or pry it out, however you gotta do it. And then push it in the other one the exact same way. And do that to the other one. Just get you a nice little lip like that. Little lip. And put her in there. Just make it look like the other one when you push it in. All the metal is at one, you know, the little bump in the metal is all the same on all three of them. And take your retainer, throw it on the ground. Put the retainer back in. Okay, this should work better now. So if we look at the plugs, we'll see the reds on the right side, the pinks on the one side, and the blacks on the other one. And that's with the two tangs matching, which is what we want, so yeah. Okay, so while we're at it, I didn't get any reading before, obviously, because it was hooked up to the wrong damn wire. Yeah, that never feels good because it could mess with the ECU, could mess with the sensor. So, yeah, we're gonna go ahead and put in the ground reference right now because I'm like, it's all or nothing. So I'm just gonna strip away a piece of the middle of this, like I'm an evil vampire clip. I can be corrected. It's fine. I'll live. So we got copper wire, right? So if you use a steel piece like the standard stuff looks like galvanized plated steel, you know. I don't know where it is, but there's something called the anodic index, and the speed at, well, from my experience, the speed at which it corrodes is when two items on the anodic index are further apart. It just speeds it up, galvanic something or other. Okay, race fans, let's hope this starts. What do you think? I think I got a better chance this time. I think we got a better chance, and hopefully nothing hits nothing important. Turn the oscilloscope back on. with science. I'm going to call that one a win. We saw all the right numbers. Now I should be able to go solder that junk together that I made and put it in line, put it on the oscilloscope, and see what we get. So these little Wago connectors are pretty cool for stuff like this. We're just gonna hook it up real quick and we can take it apart. Easy. It's got them little lever locks. So what we did, we just run the signal wire in there and my little doohickey. But make sure you got the right, it's got to be going the right direction, but the oscilloscope will tell us that before we hook something up, you know, that could hurt something. Okay, shut this thing out. Mouth close-ups. I know, I got the most prettiest one. I have completed my dental plan, if you must know. Okay, so good deal. It was only a top of like 3.6 volts, and that's perfect. As long as the threshold on the DataMonster can handle that. But 3.6 volts, even when I revved it up, I was just making sure the duty cycle of the 12 volt didn't want to override it. Probably chop out one of those Zeners if I have too low of a voltage. So I say we hook it up, see what we get. Okay, we'll give it the old smoke test. Come on, baby. All right, everybody's got power. Nobody exploded yet. I will take it. I will take it. Now let's make RPM on here somehow. Let's go set it up in the module. 4-channel. It's going to be enable. Ah, there we go. Should be engine speed and velocity. Engine RPM. Okay, okay. RPM. Now let's put it in the damn thing, right? If I go to RPM, RPM it says 0. So I guess we'll see what happens. We're gonna go voltage divider on this deal. it's a little more, I got it a little way more accurate. We're getting a nice 5-volt signal, nice and strong. All right, so we're gonna take this and put a little wire covering on it. So weird that that's about what we come up with before also, with a totally different configuration. Now if I try to set this to 7.3, it won't let me. It's very picky about it. The 7.2. I clearly pressed 7.3. No, won't do it. Do 7.4. Yeah, I don't know. Okay, now we can rejoice. You saw them numbers match? I don't know. Maybe there's another way to do it, but that was kind of fun. A little bit of math. Once you find your numbers, so like say I found it idle, and then with my scope, I found it idle. So this will be good for a GM Gen 3 4X. And so we had about a little over 7 hertz at 900 RPMs. So that's what I just put in 0 and 0, and obviously it'll be in the video. I put I started out with 7.2 and 900 hertz, and then it worked out, and I didn't think it was going to be super linear. I mean, or I guess regular linear. I didn't know if that's what it was going to end up being, a line, as far as like a multiplier. I guess that's probably what it is when you think about it, but I didn't know. I mean, just get so excited. Engine's turning over, it's making noises. Okay, awesome. So we got a good enough signal to the DataMonster, and we got a simple enough setup under the hood. So now I just need to wire it in permanent, and we'll be good to go. I'm gonna shorten them wires up and that cam wire and do a couple other things. Anyway, here's what we come up with. We got the banks, the wire that goes directly into the DataMonster connection, channel E, cam sensor to computer, and to cam sensor. So